So here we go. Best part about 14.3 that a lot of you are really excited about, it's the last notes of the year. There are no more notes after this. After this is just review, test, and then review for your final and test on that final. And so then we end the semester and head off into the sunset for summer, right? The last section deals with two-way frequency tables. They call them two-way tables. It's basically a table that has some sort of identifying measure on the left side on the rows, and then it has some other identifying information in the columns, rows and columns. They also have these totals that are on the side that you're going to be using, and primarily you'll use them most of the time, except I do not think you should use the totals when they intersect. A lot of times, because we're talking about a row and a column, we may use those totals, but if it will count something twice. Let me show you what I mean. If I use the number of trucks and I say, oh, there's 70 trucks, and I say the number of vehicles that are white, and that's 100, and I say, oh, that's out of 170, well, you just counted trucks that are white twice if you use this total and that total. If I'm saying how many trucks and vehicles that are white, you don't want to count the same thing twice, so be careful about using these totals when you have a row and a column that intersect. That's what this first paragraph says. Be careful on those ones that have the word or. We're still going to use the and, which means both, and the or guide in 14.2, same idea. The only thing different is that we're introducing something called conditional probability. Conditional probability is, instead of talking about out of the grand total, we're going to be talking about a given condition, and it's out of the given condition. If you see a vertical bar, let me show you what I mean. Here's a vertical bar. Car, this vertical bar means given. Car, given, blue or red. That is a conditional probability. It means instead of you talking about out of the grand total, we're only talking about out of that given condition, and you just ignore every other condition. You just do things out of there, and I'll show you how that works as we get to that example. The last thing you need to know are whether things are independent or dependent. A lot of times when something is dependent, it influences the next thing that happens. Things that are independent are not influenced by the previous things that happen. For example, if I flip a coin, I get heads. Flip a coin again, heads. Flip a coin again, heads. Flip a coin again, heads. When you go to flip the coin the 6th time, it doesn't matter what happened the first 5 times. It is still a 50-50 chance of heads or tails. The chances are still the same. It's independent of each other. Dependent means that it gets influenced by something that happened before it. Now, if we don't know, there is a way to test it, and we'll do that today. If the probability of whatever event A is multiplied by the probability of whatever B is equal to the probability of both of them, then they're independent of each other. We're going to have to test that on 2 of our questions in the worksheet. So let's do some examples. I chose, here's 1 through 9's table. I chose 2, 5, and 8. It says, what's the probability of white or truck? Here's white, vehicles. Here's trucks. Now, if I use the totals, 70 and white, it's not it's not 170. Paramo. Yes, he is. Sure. What about Bryson? Where you at? Mr. Hall wants to see you. There you go. So, kind of wish I didn't record that, but hey, it is what it is. It's live. That's live. That's what we do. White or truck? How many are white? 100. How many are trucks? 70, but don't add them together because then you're adding the 22 twice. What I do is I usually pick the number that's the easiest. I go, trucks has 1, 2, 3 things. That's 70. Here's all your trucks. Let me just kind of circle that. That's a total of 70. Plus how many others are white? 78. 70 plus 78 means that we have 148 out of a grand total of 200. 148 out of 200, I usually put it in my calculator and I let it reduce it for me, which reduces to 37 out of 50. So what I'm cautioning you about is if you use this total, it will end up being the wrong total because we had 148. We don't want to duplicate what we're counting. I hope that makes sense. Erase that too. Red and white. And means both. Red and white. How many are red and white at the same time? It's one of those trick questions. These are the blue, these are the red, these are the white. How many are both? It's 0. That was on the previous worksheet as well. There were some questions where, well, that's mutually exclusive. You can't be red and white at the same time. Not on this particular chart, at least. Now, here's that line that we talked about. Conditional probability is different. Conditional probability means we're going to be out of whatever this condition is. It says blue or red. Here's your blue or red right there. It means ignore the other conditions. I don't care about any vehicles that are white or these other totals. You ignore every other condition. Your new denominator are the blue and red vehicles, which is how many? 100 of them. Well, how many are a car that are blue or red? Notice we're not counting anything over here. How many are a car? Well, I have this many cars that are blue or red. 52 out of 100. Let me reduce that. I usually will write my fraction off to the side, and then I put my final answer on the line in lowest terms. Hopefully that makes sense to you. Basically, your condition means ignore everything else. And sometimes your conditional probabilities will be columns. Sometimes your conditional probability will be a row. Don't be afraid to ignore a row if that's the condition. Which then, I want to take you to number 17. We'll do the chart first. Number 17 says 80 people from Fresno visited New York last year. 55 of them visited Buffalo. Let's write Buffalo right there. Buffalo. 40 visited Rochester. Never been there. 30 people visited both Buffalo and Rochester. That's the easiest number to plug in. If they visited both, that goes in the middle. But when it says 55 of them visited Buffalo, this is combined. It's a combined total. We don't put the 55 there. We have to know that everybody that went to Buffalo, the 55 people did, that includes 30 people who also went to Rochester. So what you have to do is figure out, well, what goes here? Who only went to Buffalo? And that should be 25 people. 25 plus the 30 makes a total, a combined total of 55 people who went to Buffalo. Now, who visited Rochester? 40 people did, but 30 already went to Buffalo as well, so we just need to add 10 more. Now, if you think about that, you have 25 people plus 30 people plus 10 people. You have 65 people. But it says 80 people from Fresno visited New York. That's the state. We only counted 65 people. That must mean that some people did not go to Buffalo or Rochester. Maybe they just went to New York City. Maybe they just went to Manhattan. Other places in New York that I've never been to. So that must mean 15 additional. 80 minus 65 would be 15 people didn't go to Buffalo or Rochester. We need to write that in the bottom box as the people who didn't go. And then what we can do is we can answer this question. There's several questions they're going to ask you. I decided not to do those. I decided to do the 22 and 23 with you just so you understood how to do it. Number 22 says, are the events visited Buffalo and visited Rochester mutually exclusive? Does visiting one mean you don't visit the other? Are those two separate events, or is there any overlap? If there is, the answer is no. The answer? No. Some people visited both. Mutually exclusive do not have, cannot be in both. 23 says, are the events visited Buffalo and visited Rochester independent? Now you might think, well, does this depend on that? Maybe. But there's a test for it. Justify your answer mathematically using the test for independence. Earlier we wrote down, what's the chances? What's the probability of A times the probability of B, and what's the probability of both? Here's what that means. The probability of going to Buffalo, I'm going to put probability of Buffalo, okay, just like a big B. There's how many people who went to Buffalo? It was 55 out of a total of 80 people. The probability of going to Rochester was 40 out of the 80. And I haven't reduced these because I don't need to just yet. And then what's the probability of going to both Buffalo and Rochester? There were 30 people out of 80 who went to both. So if I want to know if it's independent, then what I'm checking to see is, what does this times this equal? And does that equal the 30 over 80? That's what we're checking to see. So I'm going to take my calculator, I'm going to press 55 over 80, and I'm going to multiply that by 40 over 80, or 1/2, same thing. This is what I get for the probability of B and the probability of R. Now over here, if I reduce this, this is 3/8. Are these equal to each other? If they are, they're independent of each other. Well, they're not equal. So that must mean these are not independent of each other. They must be dependent. And you don't know why. We could come up with a logical reason, like maybe in order to get to Buffalo, you have to drive through Rochester. Maybe you visited that because you went through it. Maybe you had to go through Buffalo to get to Rochester. It depends where the airport is or which airport you landed in. That might be a reason why you would do both, and you had to. They're not dependent. One depends on the other. Possibly. I don't know. But that's where we're going to stop your notes.